First upgrade we did is we hand cut out the faceplate to fit the larger switch. We now have the 10 amp thermal overload breaker switch in it. Optionally, we have a 16 and we have a 7. The 7 will be for the smaller motors. This should be correct. If you're popping it, then it'll go up to this one. Testing the original motor, we found that the fan would actually blow air out and suck contaminants in along the leakage around the wire plugs. We've reversed the fan, put a fan filtration system in it. Now it sucks air in here and blows out here. I will show you. See how it pulls all the smoke into the fan like that? And then if we check here, the smoke is blown away. See how the air's coming out? That's going to stop the metal filings from automatically getting in there. That doesn't mean you can just leave this in a pile of metal filings. But during your normal machining, keep your shop clean. You shouldn't have a problem at all. This fan has a replaceable filter right here. Currently it does filter. We're going to get a die cutter and make our own filters with a little better material, but for now that'll be good. There's also a screen inside. I built the 1500 with the new control unit for an AT300, Smithy AT300. We're going to use it as a base control unit and do a factory test at 3500. See what temperature it reaches. It's currently at 71.2. We will run it at 3500. Controlled temps starting at 1204. We'll check it and see how hot it gets. It's under no load, but it's also running a lot faster and you're going to run it most of the time. After running at 3,500 RPMs for 5 minutes, we are at 83.7 degrees. 10 minutes at 3,500 RPMs, 90 degrees. As you notice, this motor has air access all 4 sides. Now we're going to run the same motor, but we're going to block one side with foam so it can only cool on 3 sides. We'll run it at the same speed. Start time 12:16. Temperature 72 degrees. After 10 minutes, we are running 90 degrees, so it's still running cool enough. Even with 1/4 block, so it should work okay. Hidden in some machine. Okay, we have overclocked it. It's currently at 96 degrees. It's already hot. We're going to run it for 5 minutes at 5,000 RPM. One side block. After 8 minutes, it is at 105 degrees Fahrenheit. Still plenty cool enough. On the last motor, you saw me putting my hand on the motor, 105 degrees Fahrenheit. Really made me wonder if this was accurate. I tested it. It is. 105 is too hot to leave your hand on it for any amount of time. I've seen the motors too hot to touch. We have a cooling kit, thermal glue, heat sinks, 3D printed shroud. I'll show you it in order on the motor. You're not going to need this except for in extreme cases. We're going to overclock the motor to 5,000 RPMs. I don't have a dyno. I don't have a way to put a load on it. Trust me, it's going to produce a lot more heat if you're running it under full loads. Okay, this is the motor with the thermal cooling system already installed. The controller already has it installed. We're starting at 103 on the clock. It's overclocked. We're going to run it at 5,000 RPMs. But first, let's get a temperature reading off the motor. About there should be good. Start temperature is 73.6. 104, we're going to run it for 10 minutes approximately, and we'll see where it reaches. Okay, 10 minutes at 5,000 RPM, 93 degrees. The fields are right in the center here, all the copper windings. Right there I can get 105 after 12 minutes at 5,000 RPM. 101 just that far away. 81 on the cooler. 104. 91. That would explain why the motor is too hot to hold on to. It must be a lot hotter than 105 on without this. Because I can hold on to it here at 105, no problem. We'll give it another, we'll let it run 20 minutes at 5,000 RPM. Okay, 20 minutes at 5,000 RPMs. Temperature 93. Hot spot 111. Everywhere else 90, 98 right there. 100. I can still rest my motor on this, my hand on this motor, even in the hot spot. So that other motor must have been running hotter than that. I don't know, it's inconclusive. If you have a very hot motor, chances are you programmed this wrong, or you're running it too slow, not allowing the fan to engage. If you're really going to work the motor and overclock it, you may want to consider buying the cooling kit. Maybe just wait and see. This is what the motor cooling system consists of. It's 2 heat sinks, thermal glue, 3D printed fan shroud to replace the existing. If you look at the motor, you can see this little edge here and this edge here on this side. You're going to want to glue the heat sink to the motor on each side. It's going to go on the side towards the wires up this way, because generally this is the slot that a mount would be bolted to. So it's going to sit right there. You want to make sure that you take this shroud off and put this on so you can line it up correctly. Glue one side at a time, let it sit with a weight on it, probably 2 days, and then flip it over and do the other side. You may want to consider emery cloth this surface and this surface, just to give it little microscopic scratches so that the glue sticks better. I'll explain the control unit next. This is the thermal overload switch, and this is the cooling fan for the control unit. That's all we have to do to these. I'll show you how to put them in. Start by removing this screw, and after pulling the faceplate forward, remove the 2 top screws, and then you should be able to remove this plate far enough. Unplug this wire, unplug the switch wires. There's a little release on these right here. It's just a little button right there. You push that to release the lock. If you look closely, the power switch, the reverse switch, the power switch, plug and switch, same color. It's plugged in, power switch, by the power feed. Release the lock and unplug. Reversing switch. Release the lock, unplug. And finally, the potentiometer wire, 3 wires. Now you can remove the faceplate. Unplug the aluminum braking resistor. Now you can move this aside. Remove the nuts. And while you're doing that, notice there's no writing on the fan. You may need to unscrew some of these screws to get them to come out. They're a little tight. When you remove the fan, the screen is going to stay there. When you reinstall it, you're going to put it with the lettering facing you like this. Open the fan. Separate the filter from the cover. Install the 4 screws like this. Next, hold the screws in, put the screen on the inside, put the fan motor on. Again, some of the screws have to be screwed in because they're that tight in the fan. Notice the wires pointing towards this and the lettering is showing. Thread it in by hand if you have to. Notice they're just snug. Don't try to tighten this down like you're screwing them up or on your car. Okay, so the filter goes in the fan shroud and back on here. You may want to fit that with a coffee filter instead. I'll get to that later. Set that aside. Next, we want to replace this switch with this switch. I actually prefer to remove these and even the display before I start cutting on this cover. It just gives me more room. So remove the screws. There's a nut here, there's a nut here, there's a screw right here, and a nut there. Before I take this switch out, I want you to notice these wires are almost hitting it. That means this switch, we're going to cut it out on this side. There's plenty of room for the square to get bigger this way, not this way. Again, this switch is going to go to the outside out here. To remove this switch, we're just going to push on this little release tab, both sides. And it's out. So I just took a felt pen and drew a line. It'll wipe off the shining surface. It's approximate the size of the switch. It's going to go a little lower, a little higher, and to this side. And I'm going to take a razor knife and just slowly start cutting away at it and see how it goes. Probably cut from the inside like this. And just keep working on it until I get it there. There's a press cutter that I have that I might put to use, but this should work. Since you probably don't have the press cutter, maybe do it like this. Very carefully, of course. So to cut it out, I'm just slowly whittling away on it. Cutting a little bit at a time, just little thin layers. I'm holding it wrong here. Hold it away from you, not toward your finger. I'm just trying to show you how it's done. You cut yourself this way, but you just keep chipping away at it a little bit at a time until you get to where you need to be. And when you get close, then you start fitting a switch. It's getting real close. I don't need the ink line anymore. So fitting it, I have just, maybe a 1/16 of an inch to go. So I'm going to be real careful now and just do really thin cuts. Okay, it's cut. Now if you take this on yourself, I have to warn you, there are no replacement parts. So if you booger it up, you get to own a boogered one or buy a complete new system. We don't even sell the control unit separate from the motor at this point. You may want to pay the extra to have me do it, but being it's so time consuming, expect to pay an extra $50 to have the updates installed. It's cut now, and it should just snap right in. Like that. And that's it. Next, reinstall all these parts. Okay, this is done and ready to install, but first I want you to consider these wires have the wrong size spade connectors on them for the new switch. I'll show you. This is the old switch and this is the new switch. See the size difference? Also see the size difference of the switch. This switch has to have really small contacts in it, and the startup surge on powering up this control unit, because the large capacitors throws quite an arc. You can see it inside this switch. That's why we're replacing it with this switch. Not to mention this has thermal overload protection and this does not. When we convert these wires, we're going to use the high-end locking. It requires a special tool. We don't expect most people to have the tool or the patience to use these. We expect most people will use these. And actually that's a high-end tool as well, but most people have a cheaper version of it. We don't include these with the kit. If you ask, maybe we will, but we expect you realistically to have your own. Doing a motor conversion is not something that an unskilled person would do. If you expect us to do it all for you, buy it already done. We're not going to actually have the time to walk you through every step of the way, so watch the video instead. So we're just going to cut the old ones off. We've already done the two in the controller. Strip them and put those on. Pretty easy with practice. It's still a little lumpy. This one too. Okay, if you look close at the main board, you can see an L here that stands for line or power, and there's an N over here that stands for neutral. So we're going to put the brown wire on the neutral. In China, line, or what we consider hot, in USA it's AC, but what we consider hot, in China it's blue. In USA, home circuits, it's black. So we put that like that, and then we need to hook this up. So we're going to start plugging things in. Remember, power switch by the power wire. Reverse switch right next to it over here on the side, right there. And then we got the speed potentiometer right next to that, right? There. And then we got the display right there. We set that like that so it's ready to go together, and let's stick the wires out of the way. Oh, this switch, can you see it? Yeah. Line from the plug is going to go to the bottom two of the switch. Off, bottom two. These are where your power feeds come in, neutral, either side, positive, either side, but it's the same thing across. It's double pole, single throw. So this circuit across here and across this side. So we're going to hook the line coming in to the bottom two, like this. And they are locking. And then on the board, we're going to match it coming up to the top. You'll know it's wrong if when you plug it in, the light comes on. You'll know it's right when you turn it on, the light comes on. Plug this in here, and the fan goes right there. Set this on top first. And then we'll go ahead and screw the back ones in. And then the front. You may find these have been replaced with Allen's. Okay, let's test it. Okay, no light plugged in. Turn it on, it lights up. Otherwise you got those wires crossed I was just talking about. It's already been overclocked, it'll run 50. Warm it up slowly. Everything works. Now, let's test the fan. Yep, the fan sucks the smoke in. That's pretty much it. Stop to full speed. Instant. Reverse. That's adjustable. Stop. Pot speed control. Set your top speed. If you want it to stop and start at a different speed, we'll set it to 3300. There's more functions, but I'll get into that later. I hope you enjoyed the video. In case you're wondering, I am going to sell the demo unit. It has all the current upgrades on it, all the current cooling systems. They'll be in the clearance on our main page, https://www.servomotorkit.com. Click on the link that says clearance.